Good morning, everyone. I am Fazilat Fatima, lecturer of chemistry subject. So, my dear children, we use a many sort of acid, base and salt in our daily life. So, today we shall study about what are acids, uses and its properties, as well as base and its uses and its property in the same meanwhile salt and its uses in our daily life. So, you might have seen acids, bases and salt in not only in laboratory, in your daily life basis. So, how? In sense, the acids are those which are subdivided into organic, inorganic acids. So, you might have seen many of organic things that we can see in our daily life is some sort of fruits like grapes and orange. These are all organic acids, and lemon as well. It is also an organic acid. If we come to the inorganic acids, this, for example, if we say hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3, these are all not only we see in laboratories, we can see these things in our daily life as well. So, in this class, we shall study one by one the acid, base and salt and the importance of pH. So, before going to such properties, we shall understand what is an acid. An acid is a substance that produces hydrogen ion when placed in water. So, you can see in the reaction, when hydrochloric acid dissolves in water, it provides an ion that is negative ion and positive ion. Negative ion where chlorine consists of negative ion and hydrogen consists of positive ion. So, when these ion acids and ionic compound are dissolved in water, the ion split apart from each other. So, here splitting apart from each other is considered as dissociation, means the breaking up of ionic compounds. We can see here the hydrochloric acid dissociate to form chlorine ion which is negative and hydrogen ion which is positive. Next, if we come to the properties of acid, acids are sour in taste. For example, if we see in our life, we almost use lemon for our dieting purpose. So, does it taste sweet? No, it tastes sour in taste. So, when it reacts with many metals, it releases hydrogen gas. So, these acids are more corrosive in nature. That means if somehow acid will if you put on your skin, do not try this, it will burn your skin. So, it is called as corrosive. So, if we see the reaction with the metal and acid, we get hydrogen gas liberated and zinc chloride we will get. Next is somehow common acids, before I have told you, that is organic acid and inorganic acids. These are all common acids which we can see in our daily life. Those have been listed here. So, organic acids, for example, acetic acid, The chemical formula of acetic acid is CH3COOH. So, we can use this acetic acid in our laboratories and in our home in daily uses. For example, we use this acetic acid to prepare the vinegar. You might have heard the name vinegar, which we usually use in our food to increase the taste. And citric acid, that is the chemical formula of citric acid is C6H8O7. This citric acid we will find in a lemon. And formic acid, the chemical formula of formic acid is HCOOH. And meanwhile, inorganic acids are hydrochloric acid, that is HCl, H2SO4, that is sulfuric acid, HNO3, that is nitric acid. So, if we see the classification of organic acids, that can be classified as organic and inorganic acid, acid which are present in plants and animals are called as organic acids. These organic acids where we will find in plants and animals. For example, acetic acid and formic acid. Where do we find the formic acid is? You might have seen somebody has got stinged from the ant. So, we will get itching in our skin. So, the ant itself produces formic acid to defend with other animals. So, it is called as formic acid. Acetic acid I have told you earlier. Inorganic acid, acids which are obtained from rock and minerals. Where do we get minerals? We get minerals from you have come across the in Kannada I will use to tell Ganigarike. We find plenty of minerals in that, which we use in our daily life, in acid and ornaments as well, gold, platinum. So, if we see this inorganic acid, the example for inorganic acid is HCl, nitric acid, sulfuric acid. So, next is bases. What do you mean by base? A base is a substance that produces hydroxide ions when placed in water. See, when bases reacts in water, it produces hydronium ion, whereas in acid, if it produces in water, it produces hydronium ion. There is a difference between hydroxide ion and hydronium ion. Hydronium ion is H plus, hydroxide ion is OH minus. So, you can see here in this reaction, when bases and ionic compounds are dissolved in water, the ion split apart from each other. So, before I have told you the dissociation. See here, when bases are dissolved in water, the ions get splitted. See, when I put sodium hydroxide inside the water, it will get reacted and split apart, and we will get both of the ion, that is positive ion is sodium and negative ion as a hydroxide. These are all bases. So, when we come to the properties of bases, most of the bases are bitter in taste. Bitter in taste. For example, here they have been shown, the broccoli. And then the bases feel slippery. Why they feel so slippery in sense? They dissolved fatty acids and oil from the skin, and it reduces the friction between the skin when you rub the fingers between each other. So, this is the main reason why we feel slippery when we touch the base. For example, you might have seen the soap in your home. The soap consists of bases. If you rub your soap with your fingers in your hand, you might feel slippery because it will reduce the friction between your both the fingers while you are rubbing. Got it? Next, they are corrosive as well. If you see in your laboratories, there might have kept a strong bases. Sodium hydroxide. So, these are all strong bases. If you just touch it, it will get burnt on your skin or you will start itching suddenly. So, they are considered as corrosive and have a chemical formula that ends with OH. I have told you, when the base dissolved in a water, it releases OH ions. So, when the acid releases, when the acid get dissociated, it will release hydronium ion which is H plus and OH is OH minus. Next, the common bases. So, in our daily life, what we all use in our common bases? Ammonia, which is used in cleaners and fertilizers. See, you might have heard about urea, which our farmer uses as a fertilizers in agriculture to get more yield. And cleaners, and for the hair dye, we use ammonia for the hair dye. So, it is most dangerous when you just keep on dyeing your hair. So, avoid doing such things. These are all the things comes under base which we use in our daily life. Next is sodium hydroxide. Where do we find sodium hydroxide in our life? In sense, it is used in the preparation of soaps. Sodium, the chemical formula of sodium hydroxide is NaOH. And drain cleaners, floor cleaners, these are all consist of sodium hydroxide. Magnesium hydroxide, an ingredient found in antacids. These are found in antacids. So, next, indicators. What do you mean by indicators? See, if in our laboratory there are plenty of chemicals which are colorless in nature. If we see it, find as a colorless, whether it is a strong, whether it is a base, whether it is a strong or a weak, acid or a base, it will be like a plain watery in color. So, how do we find whether it is a strong acid or a weak acid, whether it is a strong base or a weak base? We cannot touch it and we cannot just find out whether it is acid or base. There are, because it is corrosive in nature as well as in a base as well. So, what do we do? So, we use indicators. So, indicators, what are these indicators? Indicators are used to determine if a substance is an acid or a base. How it will determine? We shall study further. An indicator changes a specific color when it is present in an acid or a base. When it is present in an acid or a base. For example, litmus paper. You might have come across litmus paper. There are two types of litmus paper. In your school days, you have been studied. One is red litmus paper, another one is blue litmus paper. So, litmus paper, what are these litmus paper? It is an indicator made of special filter paper that contains dyes extracted from lichens. Lichens, where do we find these lichens? These are crusty stuff that grows in rock. The best example for another lichens, if you see the white particles on a plant, white bacteria kind of that round color stuff which is present on the branches of trees, that is considered as a lichens. So how does it work? How does it litmus paper work? When blue litmus paper dipped into the acid, it will turn red. This considered as a acid. So it will confirm that is acid. The present solution is acid. If we take the red litmus paper, or you can see like pink color litmus paper, if you dip into the solution of base, it will turn into the blue. So the present solution indicates that that is consist of base solution. Okay, why do you think it's important to test an unknown solution with both type of litmus paper? So here one type of litmus paper does not change a color. That does not guarantee that the other type of litmus paper will change. For example, water. Water is a universal solvent. So it doesn't just change any sort of colors when we dip red litmus paper and blue litmus paper as well, because water is a neutral solution. So we can see the types of indicators here. Indicators showing different colors in acid and base medium. So which are those? Those are natural indicators, synthetic indicators, and what are these natural indicators? Litmus paper, which we studied before, that is made up of lichens stuff, bushy stuff, and the red cabbage. You might have seen the red cabbage. It is also one of the natural indicators. Synthetic indicators. So if we come to know, if we see the phenolphthalein, we might see in our laboratories. Phenolphthalein, methyl orange, these are used in our filtration, burette reading purpose. These are synthetic indicators. Indicators giving different colors in acid and basic medium, and these are considered as an olfactory indicator. For example, you might have seen the onion in your home. So these are all olfactory indicators. So it will give odor, some burning odor, some, if you just inhale the air where the acid is present, if you take the suddenly if you take up the vinegar and you just smell the odor of it, it will just like uneasy, you feel uneasiness. This is called as olfactory indicators. For example, onion and clove oil, which almost it is present in everybody's home. These are the types of indicators, which are natural indicators, synthetic indicators, and olfactory indicators, which are present in your home as well. Olfactory indicators you can see in your home, that is onion and clove oil. So you have been provided, if you would have taken, if I would have taken the laboratory, I would have done this. So just simply I am telling this. You have been provided the 3 test tube. Just imagine, because it is online class, one of them contains distilled water, one test tube consists of distilled water, and other 2 consist of acidic solution and basic solution respectively. If you are given only red litmus paper, how you will identify the content of each test tube? If the red litmus paper turns into blue, that is considered as base. One of the that is third test tube which you have basic solution. If you dip your litmus paper into the basic solution, that will convert red into blue. So it is considered as a base. Next, so we can see, we will study the reaction between the metals and with the metals with the acid and base. How does it react? When the metal undergo reacted with acid, what do we get? When the metal undergo with the base reaction, what do we get? So with the acid, what happened when the metal reacted with the acid? What do we get here? So for example, we have taken here solid as a zinc and the acid is H2SO4 aqueous. Below within the bracket we have shown aqueous because we will take a aqueous solution, that is liquid solution. When both of these reacts with each other, we'll get zinc sulfate and hydrogen gas get liberated. If we react the same zinc, another zinc as a solid, zinc crystals, and we add 2 ml of HCl, that is hydrochloric acid, which is in aqueous solution, we'll get zinc chloride and hydrogen gas get liberated. What happens with the metal reacts with the base? The zinc reacts with the base, we get Na2ZnO2, that is sodium zincate, and hydrogen gas get liberated. Next, what happens when the reaction of acids and base with the metal carbonate and bicarbonates? So we shall see the examples here. Sodium carbonate reacts with the 2 amount of HCl, will get 2 NaCl, that is sodium chloride, salt, water and carbon dioxide. Next, sodium hydrocarbonate, hydrogen carbonate react with the hydrochloric acid, will get salt, that is NaCl, and water and carbon dioxide get liberated. Here, if we do the test for carbon dioxide, if we take the lime water, that is calcium hydroxide, that reacts with carbon dioxide, we get the calcium carbonate, which is insoluble in water. What happens if it get insoluble? If it is soluble, then it is okay, it is solution. If it does not soluble in a water, it will give a residue, white color residue. That is considered as that is called as calcium carbonate and water. Again, this calcium carbonate reacts with the water and carbon dioxide to give CaHCO3 2. So we got here carbon dioxide that is soluble in water. And reaction of acid with base, we have studied the acid reacts with the water, base reacts with the water, what do we get? And the metals reacts with the acid, what do we get? Hydrogen gas will liberated, and the base reacts with the metal, that we get carbon dioxide get releases. Metal oxide reaction we have come across with the many reaction. Now what happens when acid reacts with the base? Sodium hydroxide, that is NaOH, reacts with hydrogen chloride, give rise to sodium chloride and water. For this reaction we call it as neutralization reaction, because it is a neutral. Where we find the water here, we call it as a neutral solution, neutralization reaction. So if we take the concentrated sulfuric acid with the base, the 2 ml of NaOH, sodium hydroxide, that gives rise to Na2SO4 plus 2 amount of water. This is called neutralization reaction. Next, the reaction of metal oxides with acids. Here we have taken aluminum oxide that reacts with 6 ml of hydrochloric acid, we get AlCl3 plus 3 amount of water, aluminum chloride and water. Next come with the another metal oxide, that is zinc oxide, reacts with the strong acid, that is H2SO4, which we call it as sulfuric acid. We get zinc sulfate and water. Reaction of non-metallic oxide with base. So, non-metallic oxide is CO2, carbon dioxide plus calcium hydroxide. These both will get reacted to give calcium carbonate and water. Which is calcium carbonate here? CaCO3, which is in product side. Next, the pH. See, this pH plays very much important in our life, in our daily life. For example, the best example I will give you, which we can see in our daily life, is acid rain. The pH level which is less than 5.6, it is considered as a acid rain. And pH level will also play an important role in our daily life, that is during digestion. So, in digestion we use hydrochloric acid. It plays a very much important role, and for the pH of soil is also very important for the production of plants in agriculture. So, the pH scale can also help us to classify the solution as a bases and acids. pH is a measure of an amount of hydrogen ions in a solution, that is considered as a potential hydrogen. The more hydrogen ion, the lower the pH, the more acidic the solution. The solution will be more acidic if the hydrogen ion is more. So, we can see here the pH scale. So, if we see the less than 7, it is considered as a more acidic, and the more than 7, it is considered as a more basic. So, in a soft drinks like a cold drinks, what we use, it has less than for about 2 to 4 level of pH. So, it is very dangerous to our health. So, we have to control our habits for having such kind of drinks in our life. That soft drink consists of carbonate ions, carbonic acids. See, we as human beings, we inhale oxygen and exhale carbon dioxide. What we are doing nowadays in a fast food kind of days, we just take cold drinks for our digestion. It is very much bad habit. So, it will harm our digestive system because it consists of carbonic acids. So, here we can see the vinegar, the gastric content, which it is considered of between the 2 to 3 level, and the tomatoes, it is consist of acidity 4 to 5, and here you can see the milk, it is for about base, milk is considered as a base, and here 7 is a neutral, here comes water, 7. This baking soda, ammonia, dry cleaning, milk of magnesia, blood plasma, these are all bases. So, when describing acids and bases, strength and concentration do not mean the same thing. Why? Because strength refers to the ability of the acid or a base that dissociate into the solution. Dissociate means just spreading, dissociate, breaking off ion particles. So, here pH measures such things, the strength. Dissociation refers to the ability of an ionic compound to break apart into the ion, In a previous slide I have been shown you how the acid dissociate into the water. For example, if I take HCl, hydrochloric acid, if it dissolves in a water, it gives rise to one is positive ion, another one is negative ion, that is H plus and Cl minus. This is considered as a dissociation. What do you mean by concentration? Concentration refers to the amount of acid or a base dissolved in a solution. See, there are both of the difference here. One is dissociate and one is dissolve. Dissociate is just breaking apart, and dissolves in sense it is completely dissolved in the solution. So an acid or a base will have the same pH regardless of how concentrated it is. Just because you add water to dilute it, it still going on to have the same amount of hydronium ion. They will just be spread out more. That's it. Next, if we see here the strong acid versus weak acid and base, you can see here when a strong acid or a base dissolved in a water, nearly all acids or a base molecule will dissociate into the ions. You can see here hydrogen ion, chlorine ion, the plus and minus ion. Okay, the greater the ability to dissociate, the more potential the acid or a base has been dangerous, because these are more ion available to react. For this sake, it is very corrosive in nature because it is a strong and it has very much potential for being ability to dissociate. The more it dissociates, the more it gets stronger. So when we come to the weak acid or a base, when it dissolves in a water, only small fraction of acids or a base molecule dissociate partially. With a less ion in a solution, there is a less potential of danger. See, you can see here hydrogen, acetic acid, here acetate. You can see here there are less dissociated ions. Next, you can see the examples for a strong acids and a weak acids. Strong acids, that is HCl. The chemical name of HCl is a hydrochloric acid, which is present in a stomach. Somehow not the concentrated hydrochloric acid. If there is a concentrated hydrochloric acid in our stomach get burnt. It's just a strong hydrochloric acid. Next, H2SO4. The chemical name of H2SO4 is a sulfuric acid, where this sulfuric acid we use it as a battery acid. So you can see it in a car, in a vehicles, in a bus. These are produced from sulfuric acid. The chemical formula of sulfuric acid is H2SO4. Next is nitric acid. The chemical formula of nitric acid is HNO3. Next is weak acid, acetic acid. You can see here HC2, H3O2. Inside we can tell CH3COOH, which is present in a vinegar. Another one is citric acid, CH3C6H5O7, which is present in a citrus fruit. For example, lemon, oranges. These are all citrus fruit. Next, the strong bases. Which are those strong bases? Sodium hydroxide. The chemical formula of sodium hydroxide is NaOH. Any alkali or alkaline earth metal with OH, this is considered as a strong base. Alkali or alkaline earth metal you can see in a periodic table. For example, I have taken here potassium. So it will mingle with OH, so it is considered as a strong base, potassium hydroxide. Weak bases. Aluminium hydroxide. The chemical formula of aluminium hydroxide is AlOH bracket 3. Often found it in deodorants. This aluminum hydroxide we can see in deodorants to smell good. Then ammonium hydroxide, which is also called as ammonia, NH4 is called as ammonia. Ammonium hydroxide, this is a weak base. It is used in many cleaning products. For example, detergents, your floor cleaning detergents, cleaning products, bathroom cleaning products. Here we can see ammonium hydroxide. Next, what do you mean by neutralization? We have studied acids, bases, their uses, their chemical reaction and their properties. Now, I have told you before, the pH level of 7, it consists of neutral, that is water. What do you mean by neutralization? Neutralization is a chemical reaction between the acid and the bases that takes place in a water solution. What do you mean by neutralization? It is a chemical reaction between the acid and base. It takes place inside the water solution. For that sake, we call it as neutralization. When acids and bases react, the hydronium ion, H plus is hydronium ion from the acid react with the hydroxide ion from the base to form H2O, that is water. This is called as neutralization. The overall pH becomes neutral. The pH value of neutral is 7, that is water. And next, salts. You might have seen the main ingredient we use for the food is salt, which is present in our life for the food purpose, that is sodium chloride. The chemical formula of sodium chloride is NaCl. So, here we can see so many kinds of salts in our daily life. What are these salts? The ions that left behind after the hydronium ion and hydroxide ion form water combine to form a salt. What happens here? The left behind the hydronium and hydroxide ion in the form of water to combine to form a salt. A salt is a compound that forms when the negative ions from the acid combine with the positive ions. What happens here? To form the salt which combines with the negative and the positive ions from the acid and the base, we can say it is a salt. Here you can see the reaction. The acid we have taken here hydrogen chloride as an aqueous solution and the base potassium hydroxide as an aqueous solution. These both get reacted to form a water and a salt, that is a potassium chloride, KCl. Chemicals from common salt which we get from the common salt which we can see in our daily life. Those are caustic soda, NaOH, bleaching powder, CaOCl2. We use bleaching powder to clean our bathrooms, right? Floors. These are all bleaching powder. To kill the bacteria, we use a bleaching powder. Baking soda. This is nowadays for the fast food, people have been dependent on the fast food, that is bakery item. Most of the bakery item have been cooked with the help of baking soda. Why they use baking soda? In sense, it will make the batter or bread batter most spongy kind of things, so that we can feel very much good to have, and it is very attractive to have, and it is very tasteful. By using this baking soda they will prepare. Next, washing soda, that is Na2CO3 10H2O, 10 amount of water. We use this washing soda in washing detergents, cleansing agents. We can use this kind of a common salt in our daily life. Next, how do we prepare NaOH? Sodium hydroxide. How can we prepare sodium hydroxide? If we take 2 amount of sodium chloride, which reacts with 2 ml of water. It gives rise to 2 amount of sodium hydroxide plus hydrogen gas get liberated and chlorine we will get. For this we considered as a electrolysis of brine solution. Chlor-alkali process. It is also called as chlor-alkali process. For this chlor-alkali process we call it as electrolysis of brine solution. Next we have studied the properties, how does the base get prepared. Now we shall see the uses of sodium bases, chlorine and hydrogen gas. Why do we use it? So sodium hydroxide, which is a base used in a soap and detergent and in a paper industries as a laboratory reagent. We use base in our laboratory reagents to conduct the experiment. And soap and detergents, what you use in your daily life, soaps and detergents. Okay, then paper, to produce the paper, they help NaOH in a paper industry. And uses of chlorine, it is used as a disinfectant. What do you mean by disinfectant? Which kills bacteria. This is called as disinfectant. Chlorine, the one of the most important example, the best example which you have come across in your daily life, I will give you. The chlorine water, where you can see in a swimming pool, where they just clean the water with the help of chlorine. So it is very much useful in cleansing the water. So making a PVC, that is polymer, and it is useful in a production of a CFC, chlorofluorocarbon. It is very much harmful. It has been preparing a daily basis. It is getting more and more increasing, where the ozone layer getting depleted. This is the one of the major things. CFC, where we get this CFC is from the refrigerator, AC, air conditioner, we will get a CFC, which is very much harmful for the ozone layer getting depleted. And DDT, we all use nowadays. DDT got banned because DDT will be used in many of the source for killing the pesticides and all, and nowadays it has been decreases. Uses of hydrogen gas, where do we find this hydrogen? Hydrogenation of vegetable oil, it is useful in as a fuel. You might have heard in a fuel, while you have gone to put petrol in your vehicle, there you can see hydrogen as a fuel. For auto purpose also they use hydrogen gas. Okay. Next, preparation of bleaching powder. How do we prepare this bleaching powder? The chemical name of bleaching powder is calcium oxychloride. How do we prepare? We take calcium hydroxide, it reacts with chlorine to give calcium oxychloride, CaOCl2 plus water. Then, what are the uses of bleaching powder? They are used in textile industry for bleaching the cotton and linen. The cotton which we used to wear in textile industry, the sweaters and other clothing material, they use bleaching powder in a textile industry. And for the production of paper industry, for bleaching the wood pulp, and it is also used as a disinfectant, where the bleaching powder used to kill the bacteria. Thank you, one and all. This ends the classes.